Okay, greetings everyone. Can you see my screen?
Yes.
Okay, great. Um, I really appreciate all the work you've done with this, Amir. Thank you. These security workshops are really helpful to all of us and the community colleges. There's so much information out there to try to go through that sometimes it's a little bit easier if someone gives you a little like head start or push in the right direction to get going. And that's kind of one of the areas I'm at with Microsoft Cloud App Security. It's something that I've been investigating and researching a little bit. So I have some familiarity with it, but there's a kind of depth of knowledge that's required to really master it. And I'm not quite there yet, but I want to share the information I have so far with the group. So moving on. Um, My name is Dan Rojas. I'm the Information System Security at Santa Monica College. And I want to go through a little bit of the background. What's the driving force for us to look at cloud app security, what a CASB is, how Microsoft Cloud App Security fits in this role. And then I'm not sure where everyone's at with their kind of journey through the Microsoft Security Center, but I'll give some of the preliminary steps on how to integrate some of the other Microsoft security services into Microsoft Cloud App Security and what the steps are. And at the end of the slide, I have links to each of the individual security solutions that I'll be talking about and how to incorporate that with Microsoft Cloud App Security. So there's been an explosion of cloud applications, and with the COVID-19 transition that everybody had to go through, it presented a lot of challenges for us. And there was an immediate spike in the need for remote access for everybody to apps that the college was providing. In some cases, VPN wasn't a scalable solution to hand out to everybody. So it wasn't easy to enable access to all the resources that were needed, or we had to be discerning on who we were giving the remote access to and have other people go to applications directly, which were outside of our kind of visibility. We've been kind of punished by a lot of bad actors trying to exploit COVID-19 and socially engineer people into succumbing to different offerings or different threats that their email account was going to be disabled, or they were going to have their account limited to only a certain amount of resources. So they had to respond immediately. So that was a tricky thing to work with as well. Some of the challenges to onboarding and managing new personal devices once they're outside of your organization. How do you actually talk to the device? How do you control it when it's not transitioning through your network? Created a challenge for everybody. And then also a difficulty rolling out security controls. Like, how do you push software to all of your users outside of your campus when you're not controlling these systems directly? So that brings into play cloud app security brokers, and how Gartner defines a cloud app security broker is a technology that's the result to need to secure cloud services, which are being adopted at a significantly increased rate, and access to them from users both within and outside the traditional enterprise perimeter, plus growing direct cloud-to-cloud access. Cloud access security brokers deliver differentiated cloud-specific capabilities, generally not available as features in other security controls such as web application firewalls, secure web gateways, and enterprise firewalls, because again, a lot of the access is from outside the organization, and the sessions don't transition through these devices or applications directly. Cloud Ops Security broker vendors understand that for cloud services, the protection target is different. It's still your data, but it's processed and stored in systems that belong to someone else or hosted in another area that you may not have any visibility or control over. Cloud Ops Security brokers provide a central location for policy and governance concurrently across multiple cloud services for both users and devices, and granular visibility into and control over user activities and sensitive data. So the top cases for CASB uses are, we have the corporate headquarters, public home Wi-Fi, internal and external users, and unmanaged devices. And we're trying to lump all of these endpoints into identifying the types of access that they have and what types of sessions they're creating to different services. So what the CASB does is it first helps identify unsanctioned apps in an environment, so it can discover cloud apps as they're transitioning through the CASB reporting, assess if your cloud apps meet compliance, help you govern the discovered apps. In this example, we're showing that Facebook, YouTube, Twitter, Dropbox, and depending on the institution, some of these are sanctioned apps, some of them are unsanctioned, some of them are sanctioned and unsanctioned based on departments in different groups. Like you may have your media or your marketing group who is dealing with Facebook on a regular basis, but you may not want your admissions or your fiscal services directly accessing Facebook unless there's a business need for it, or if it can be done in an environment where you are comfortable with the security requirements that have been implemented. And then sanctioned apps are apps that are able to classify, label, and protect information, sensitive information, and apps that you can control and monitor the user sessions in real time by blocking access in real time, or getting visibility to see what type of data is being transferred in real time and when it's happening. Then also the CASB solution needs to be able to identify cloud threats, detect insider threats based on compromised accounts, or identify and mitigate malware activities. So a lot of this is done based on behaviors or locations that users may be that aren't particularly part of their normal travels or activity. And by doing that, you can identify premature or preemptively if someone's account may have been compromised, and you can take action quicker by knowing this. So what Microsoft Cloud Ops Security has done, it's taken a lot of its security components and security services and bundled them together where they can feed up to the Cloud Ops Security broker, Microsoft Cloud Ops Security, and give that visibility and insight to the different types of assets and objects within our environment. And they can do this with assets that are in the cloud, assets that are on-premise, or assets that are remote to different user locations as well. And it does this through using the identity and access management with the zero identities to reach zero trust framework, It has the threat protection and intelligence to help stop damaging attacks with integrated and automated security. It provides information protection by being able to locate where the information lies and classify information as well in any place that it lives. And for us, that's a really big deal because of all of the compliance requirements that we have. Also providing security management for SOCs and strengthening security posture insights and providing guidance on different threats that are identified. So one of the benefits of Microsoft's Cloud App Security solution is that it has an awareness of an abundance of different third-party apps. This is just a sampling of it, but I believe that there's about 16,000 apps that it's aware of, and it can identify the different threads and sessions that are connected and relate those back to the user information that's transferred as it's discovering these apps and identifying where they're coming from within the organization or within the with the users that are in your tenants. How Microsoft has kind of identified this is as a shadow IT. So the IT department typically has a baseline of applications that it's providing and supporting to the institution. But because of varying reasons, whether the applications that were provided are too difficult for users to use in their perception, or it's not meeting their business processes, users tend to discover apps that are available and start incorporating those into their workflows. And this kind of shadow IT creates a big risk for the institutions, because if there's data that needs to be handled in specific ways, protected, classified, logged, it can transition to areas outside of the institution unknowingly, and then there's no record of any of that exposure that may have occurred, whether it's malicious or whether it's intentional. So part of the Microsoft Cloud App Security solution is to have this shadow IT management lifecycle. And within the lifecycle, we discover shadow IT by identifying which apps are being used in your organization. And it says from an app catalog of over 16,000 cloud apps and custom apps. Identifying the risk levels of your apps. So Microsoft automatically provides a score of risks that may be exposed based on to the apps that it's aware of that meets compliance requirements or has the capabilities. In apps that do not meet the compliance requirements, or they don't have the technology within the service to meet those, whether it's PCI, FERPA, HIPAA. It has a catalog that includes the awareness of what capabilities are within the solution. So identifying the risk level of your apps, understanding the risks associated and discovered with apps based on more than 70 risk factors, including security factors, industry and legal regulations, with the ability to customize risk scoring. So as you know, if you have a relation with a cloud provider or a custom application that you've developed, and you can customize the risk scores to suit your institution, so that you know if you built in the controls that are required to meet these regulations or compliance requirements. It can also evaluate compliance, evaluate whether discovered apps meet the compliance standards of your organization against factors like GDPR, industry relevant standards like HIPAA readiness. It helps you analyze usage, understand the usage patterns based on traffic from top users, IP addresses, app categories, and machines, leveraging the C-level report for a higher level overview and recommendations. The next phase would be to manage continuous monitoring. So to govern your cloud apps, start managing cloud apps and leverage one of the several governance actions such as sanction, unsanction, onboarding an app to Azure Active Directory to leverage single sign-on, marking your app or reviewing or blocking them from your network through the governance. And then continuous monitoring to look for new risky or high volume apps that are discovered in your environment, and then ongoing control over your apps. And then it's a cycle. As you have new apps appear, you discover who's using them, identify the risk, evaluate the compliance, analyze the usage, govern, and rinse and repeat. So with Microsoft Cloud App Security, you can integrate a lot of the pre-built Microsoft security solutions. The first one I'm going to go over is Microsoft Defender for Endpoint and how you integrate that with Microsoft Cloud App Security. So kind of preliminary, I'm just going to gloss over this a little bit, but Microsoft Defender for Endpoints allows you to add all of your endpoints, whether they're on-premise or remotely used, and even to control devices that are personally owned within Microsoft Defender for Endpoint based on policies that you create. And the way that you onboard or get the devices connected to your environment are through, for Windows, there's local scripts available that can do, the script can do 10 devices at a time, which you have to kind of rerun to continue to add devices. You can use group policies within your Active Directory to add the Windows devices. You can use Microsoft's Endpoint Manager, MDM, which is in tune. You can use Microsoft's Endpoint Configuration Manager or VDI scripts. For Mac OS, which you can also incorporate into Microsoft Defender for Endpoint, you can use local scripts, Microsoft Endpoint Manager, again in tune, Jamf Pro, and mobile MDMs. For Linux servers, you can use a local script or the automation tools like Puppet and Ansible. For iOS, it's app-based. There's an app to connect the iOS devices to Microsoft Defender for Endpoints. And for Androids, you can also use Microsoft Endpoint Manager. Once you have your devices in Microsoft Defender for Endpoint, you can then go to Microsoft Defender, the console or the portal, and go into the settings. Then there's a lot of different features that you can enable. And this is an amazing tool. We've been using it for a while. And under advanced features, you turn on the Microsoft App Security integration. And then by doing this, it feeds all the information from the endpoints to Microsoft Cloud App Security to help centralize and bring kind of a single pane of visibility to the different types of events, threats, or activity sessions, anything that's occurring within these endpoints that you want to monitor. And a lot of this is controllable through the policies that you can push out to different devices. And like I mentioned before, you can have different policies for your institutionally managed devices or district-owned devices and personal devices based on your IT policies and how you allow people to use the services within the institution. Once you turn on the Cloud App Security in Microsoft Defender for Endpoint, then you log into the Cloud App Security portal under Settings and Microsoft Defender for Endpoint, and then enable the access or the ingestion from Microsoft Defender for Endpoint. And then you can enable logging, blocking and sanction apps. So you can then have control over the apps that are not allowed on devices based on policies. And you can have the alerts feed up into the Cloud App Security alerts, so you can view the activity or threats that may be occurring on your endpoints, or the activity in your endpoint within the same feed or the same log. So as you're doing any kind of discovery or looking for activity, it extends to the actual endpoints to help get that visibility. Okay, now we'll go on to Microsoft Defender for Identity. So in the cloud settings, it has Microsoft Cloud App Security settings. Microsoft Defender for Identity already has its own integration under threat protection. And you can enable the Microsoft Defender for Identity integration here. And it'll allow for a more sophisticated investigation experience. It'll also help feed the alerts, identity alerts that you get through the Azure Identity Protection in the Cloud App Security as well. So again, you can go to the Cloud App Security and you can look at all of these different threats or events in a centralized area. And part of the Microsoft Defender for Identity, it extends to hybrid configurations, which is what we currently have. So having that, we're able to add our domain controllers as sensors to monitor how the identities are transitioning through our internal organization and getting that visibility in Cloud App Security. And to do this, you add the sensors through Microsoft Defender for Identity in the configuration under sensors. And once you have them connecting, there's a script that you run to add the sensor to Microsoft Defender for Identity. And then there's also a sizing tool that you use because the logs are pretty sizable in order to be able to, and the amount of bandwidth is a little bit extensive to feed all that continuous activity into Microsoft Cloud App Security. But a big advantage that you get from this is that if you have a compromised credential, this is what will give you the visibility to see unusual lateral movement within your organization. So if a system is trying to, or an account is trying to log into multiple locations, and especially locations it's shouldn't be logging into that's outside of the normal behaviors, it'll trigger these activities and it'll actually identify the lateral movement as a alert and pop it up in the feed so that you can take action on it. Or you can, if it's maybe a system credential that's the normal behavior, that it's, you know, updating systems or touching systems for scanning, then that account can be categorized as a typical behavior, and then it won't feed up in the alert logs for you. or it'll still show in the logging, but it won't necessarily show up as an alert. So the next integration is connecting Microsoft Cloud App Security from Office 365. And this is a really easy connection. It's pre-built under Microsoft Cloud App Security. You go to the Cloud App configuration, you look at the app connectors, and then add Office 365 in the pull-down box. And you can see all the other apps that are here as well. So you can, in this presentation, I'm only going over the Microsoft integrations, but you can integrate the Google Cloud App Form, G Suite, GitHub, Dropbox. There's connectors for each of these different services depending on how you've integrated with these different solutions. And this will give you more visibility. And by adding these applications, it helps you track the data categories and how the different types of data are moving throughout the organization and including the cloud services that the institution is using, which is one of the big blind spots that we've had in the past. Trying to see who's shifting spreadsheets to Google Drive or Dropbox to exchange with other parties to these shadow IT practices and trying to circumvent controls because there may be limitations to the way that people are able to share or exchange information, even if it's a justified business action or practice. It may not be kind of identified or sanctioned through the IT department. It may not be recognized, but as these come about and they're justified and it's a legitimate solution, once you can enable the controls to connect to these services, then you can maintain the integrity and compliance that's required. And as you add Office 365, I recommend checking each one of the different components to make sure that you get the maximum visibility of the information out there. And one of the examples here are the Office 365 files. As you integrate this with Microsoft Cloud App Security, from the file investigation and control, you can actually see who in your organization is sharing classified information with what users, or you can look and see if somebody's sharing confidential information with everyone, or see who's sharing information with everyone, and maybe lock those down or control the share actually from within the Cloud App Security portal. So the last one I'm going to go through, the last integration, is Microsoft Azure with Microsoft Cloud App Security. And this is pretty much the same as Office 365. You just go to the connected apps and add Microsoft Azure, and then it will automatically feed the information about the assets that you have in Microsoft Azure, the users, the storage, the compute, all the different asset types that you may have within your Azure tenant. It will provide all that information to Cloud App Security and take advantage of the intelligence and machine learning within Cloud App Security. So again, I just covered a few of the security solutions, but this is an example of how Microsoft Cloud App Security takes advantage of all the different security integrations and pulls everything into the same portal to give visibility of the security tools that you have inside your organization or inside your institution. So it can use the threat signal clustering from the Microsoft Intelligent Security Graph, security and analytics security analytics and guidance by using the Microsoft Secure Score. So Microsoft uses its intelligence to help identify and feed up the risks that you may have in your institution or in the configuration of your tenants and cloud services based on the intelligence that Microsoft is gathering on the back end, so that you don't have to try to identify all the threats on your own. You're able to take advantage of this wealth of knowledge that Microsoft is providing. Cloud security posture management, IaaS, infrastructure as a service through Azure Security Center, unified endpoint management through Intune, which is the MDM that I talked about earlier. It allows you to connect to Windows desktops, Mac desktops, Linux desktops, iOS devices, and Android devices to give you control and visibility over all of these devices based on the policies that you applied to them. Data loss prevention through Azure Information Protection, identity and access management through Azure AD and conditional access, endpoint detection and response through Windows Defender ATP. Okay, and after you've gotten all of these services integrated into MCAS or Microsoft Cloud App Security, this is a kind of view of the general dashboard that it gives you. So it can help you discover all of your applications. It will automatically, through the scoring, identify users that may require investigation or who look like they're having normal than average activity. It surfaces the different alerts, and within these, unfortunately, I don't really have a good MCAS portal to do a demo where I can click on all the different devices, but basically you can click on any of the the colors and it will feed up just the high risk discovered apps or the open alerts, the high risk alerts. Here you could see one example of impossible travel activity. So this is one of the threats that Microsoft Cloud App Security can feed up into the console. You can also get it through the Azure Identity Protection, but this puts it into the same place. So Azure Security Operations Center is looking for threats and vulnerabilities in your environment. These kind of alerts surface to the top. So if one day I'm logging in from Santa Monica to Office 365 and 5 minutes later I'm logging in from the UK, that's identified as a impossible travel. And you can have policies to block that, or you can be alerted so that you can take action and find out what am I doing, you know, and then if you call me and I'm experimenting with a new VPN service, then you understand what, you know, why the behavior occurred, even though you may not like that and want to shut me down anyways. This gives you the ability to do that. This image shows 357 discovered apps. A lot of people, when you ask how many apps are they using, cloud apps are they using, they may think I'm using maybe a couple hundred, but in our environment, we're using 1,256 apps, which is way more than we had anticipated. So the discovery or the Cloud App Security Broker, MCAS, really helps provide visibility into activity that you are completely unaware of that's happening within your institution. Here in the console also, it shows conditional access control, the connected apps, the app connector instances, data loss prevention activity. It gives through the scoring and recommendations, different recommendations for Azure. It can give recommendations for other cloud cloud connectors or cloud apps that you may have connected. Here's an example of AWS. All the privileged OAuth apps that are going through your environment where people are sharing that or exchanging credentials. And then infected files that it's detected through the file detection. And you can drill down within the cloud dashboard to the list of applications that you may have based on the application type, IP address, users, machines, and give visibility into each of these different vectors that your data is transitioning through. This is a image of the different applications that are discovered and the types of score that Microsoft assigns to them. And you can filter these scores by the risk score bar on top. So if you want to drill down to the applications that a lot of machines may be connecting to or users may be connecting to that are risk level 6 or 3 or lower, and then target those and investigate and determine whether or not it's a threat to your organization by the way that the data is transferring to these different environments.
I have a question, Dan. Does this thing these are Azure AD apps that this is analyzing?
These are cloud apps.
Cloud apps, okay.
Yeah, so any cloud application that is detected from systems within Azure AD or from systems that are in the Windows Defender for Endpoint.
These all would have service principals in Azure AD then, right? Because
No, it could be have a service principal that's from an endpoint to a different provider. So if I'm going to iCloud and backing up my photos to iCloud, it doesn't go through Azure AD at all. But Azure AD, Microsoft Cloud App Security becomes aware of it because of the Windows Defender on my desktop.
All right. Yeah,
Does that make sense?
I'm covering some stuff in Azure AD. I just wanted to see how it relates to this tool. But yeah, okay. All right. Sounds good.
Cool.
Makes sense.
And you can go to the machine levels, see how many users have been accessing a specific machine, how many risky apps it may be using, how many apps in total, transactions, user history, IP address history for different devices. So it allows you to drill down for investigative purposes to see what may be happening with a system that you think is a threat. And you could do the same with an IP address, or you could do the same with a user in your environment that this is detected. I'm not sure how much time I have left, but I'm going to kind of go through the rest of this quickly. Policy enforcement. There's a lot of pre-existing policies, and you can create custom policies based on the different types of threat detection, conditional access, or shadow IT categories. We have activity policies, anomaly detection, OAuth app policies, malware detection, file policies, access policies, session policies, app discovery policies, cloud discovery anomaly detection policies. And here's a few examples of the pre-configured policies that exist. So you can have risky sign-on. If someone's sign-on looks suspicious, you can have a policy, malicious OAuth, suspected DC shadow attack or domain controller promotion, suspected DC sync attacks, suspected golden ticket usage, data exfiltration over SMB, and this is a small sampling of the pre-built policies that it has in existence, and you can create custom policies too. Like if you want a policy that will show all the users that have clicked on a link in an email message that was identified as a phishing attack, then you can have a policy that will do searches within the CloudOps security database and then bring those to the surface.
What about password spraying? I know that Azure, there's some techniques for detecting it, and I think Microsoft has some logging around that. Does that bubble up into this?
Yeah, that bubbles up into this also with the logon attempts through the risky users. So it'll show that when users are logging on from multiple different locations or have multiple failed attempts, you could create policies to bring those to the surface also. And I just provided some links on how to onboard the different security solutions that I talked about. And there's more integrations that you could do. But again, these are the kind of easy ones through Microsoft to turn on, and Azure institution is starting to use the Microsoft Cloud Services more. These are the kind of core solutions that you want to ensure that your institution is monitoring, so you can really get the visibility throughout your tenant of all the different activities that are occurring. Because there's so many different vectors that people are moving data around, attacks are coming from, threats. There's so much noise out there that it's really difficult to kind of keep track of and stay on top of everything. But through the integration of all of these tools into a CASB, the Microsoft Cloud App Security, there's some hope that we can really kind of, get a little bit better control of all the craziness that's going on out there.
Yeah, I'm covering the nuts and bolts of what's underneath this, so it should be interesting. It's kind of like a tool that kind of integrates, overall reporting and security management for Azure. It's pretty nice, yeah.
So the Cloud App Security actually kind of you can control all of these different security solutions through the individual systems, like Windows Defender for Endpoint. You can take the same actions that you can take in Cloud App Security, but to be able to do it in a central location is advantageous because a lot of times you have the same personnel looking across these different vectors.
So when it's detecting infected files, is this actually looking at files that are copied on Azure instances? I mean, like, where are these files, or is it like in the 365 mail? Where are these infected files actually being scanned?
Yeah, so these infected files, it'll detect them wherever you have the connectors enabled. So from infected files that are on Office 365 and SharePoint, or in Exchange in email or OneDrive, and even the back end of Teams, which is SharePoint also. So if you have infected documents living in these locations, also because it integrates with Windows Defender for Endpoints on the desktops. So it's looking at people's desktops that are connected to Windows Defender, and within compute and storage within Azure as well. So if you have virtual systems in Azure that are set up, it'll scan the files on those systems also, with the native integration through turning on the connectors through Azure. And then beyond that, you can have integration with Box or with Google Drives, depending on the type of setup that you have within those tenants. So if you have like an enterprise account within, or a Google tenant that you want to integrate, you can link that tenant through the admin accounts, and then through security keys, and then have it scan your Google tenant and then surface those infected files into MCAS as well, or look at categorized data that's transitioned and maintain those categories where it goes, beyond the Microsoft tenant. This is kind of moving in the direction of a SOAR. There's a seam in a SOAR. So there's a security incident event manager to monitor the or security, information event manager to manage and monitor all the data where it's moving, all the different events that occur. And then there's security orchestration, automation, and response. So through the policies here, it helps you to get to that next level where you have the automated security actions taken without requiring someone to go in and create a new conditional based access rule or to stop an activity from occurring. How much more time do I have?
I think you're already past.
Okay, I'm sorry, guys. Sorry to go on
No,
so
don't
long.
worry.
But
Finish
if
up.
you have any questions, you can reach out to me through Amir, and I'll try to get back to you.